Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam MAS 1. Modern Actuarial Statistics 1 examination of the Casualty Actual Society, but it's also a practice problem for exam P on probability. You are given the following information. Consider a system of 3 independent components, each of which functions for an amount of time in months uniformly distributed over the interval from 0 to 1. Under current design, the system will fail if any of the 3 components fail. A new design was made such that the system will fail if 2 or more components fail. Calculate the increase in expected system life in months under the new system design. And here's the solution. Let us write y sub c for the random life of the system under current design. C stands for current. Under the current design, the survival function of the system is the survival function of the first-order statistic of a random sample of size 3 from the uniform distribution on the interval 0, 1, and that means that sy sub c of y is equal to 1 minus y cubed for y between 0 and 1, and that's because the survival function of the uniform distribution between 0 and 1 is 1 minus y, and then the first order statistic is greater than something if all 3 pieces of the random sample, there are 3 of them, this is a sample of size 3 from a uniform distribution on the interval 0, 1, so the first order statistic is greater than a number y if all pieces of the random sample are greater than number y, and the probability of being more than y, where y is between 0 and 1 for uniform distribution on 0, 1 is 1 minus y. So that's why sy sub c of y is 1 minus y cubed for y between 0 and 1. And of course sy sub c of y is 0 for y more than 1. And of course this is a random variable which is greater than or equal to 0 with probability 1. And therefore the expected value of y sub c is the integral from 0 to 1 of 1 minus y cubed dy, which is minus 1/4 times 1 minus y to the 4th evaluated from y equal to 0 to y equal to 1, and that's 1/4. And of course we're using the Darth-Vader rule that tells us that the expected value of a random variable which is non-negative with probability 1 is equal to the integral of its survival function. Now let us write y sub n for the system life under the new design, where n stands for new, of course. In this case, the survival function of y sub n is the survival function of the second-order statistic of a random sample of size 3 from the uniform distribution on the interval 0, 1, and that s sub y n of y is the probability that second-order statistic is more than y, which is the probability that 2 or 3, but 2 or more, but that's 2 or 3, pieces, I should have said pieces here, of the random sample are more than y, and that's equal to the probability that 2 or more successes happen in 3 independent Bernoulli trials, with probability of success in each Bernoulli trial being 1 minus y, because each of the 3 pieces of the random sample is like a Bernoulli trial where you either are more than y or you're not. So if being more than y is a success, the probability of success is 1 minus y. So how do we get 2 or 3 successes in 3 independent binary trials with p equal to 1 minus y? Well, that's we know the answer from the structure of the binomial distribution with n equal to 3 and the probability of success p, which is 3 choose 2 times p squared times 1 minus p plus 3 choose 3 times p cubed. So 3 choose 2 times 1 minus y squared times y plus 1 minus y cubed. And then if you multiply it all out, it becomes 2y plus 1 times 1 minus y squared for y between 0 and 1. And therefore, the expected value of y sub n is the integral from 0 to 1 of 2y plus 1 times 1 minus y squared dy. That's the integral from 0 to 1 of 2y plus 1 times 1 minus 2y plus y squared dy. That's the integral from 0 to 1 of 2y plus 1 minus 4y squared minus 2y plus 2y cubed plus y squared. If you just multiply it out, then combine the like terms and we get the integral from 0 to 1 of 2y cubed minus 3y squared plus 1 dy. That's equal to 1/2 of y to the fourth, or 2/4 of y to the fourth, but that's 1/2 y to the fourth minus y cubed plus 1. Evaluate from y equals 0 to y equal to 1. So that's 1/2 minus 1 plus 1. That's equal to 1/2. And before, the expected lifespan of a system was 1/2. One was 1/4, and now it's 1/2. And that means that the improvement in expected system life is 1/2 minus 1/4, which is equal to 1/4. And that's answer D. Please remember this is copyrighted material. The problem itself belongs to the Casualty Actuarial Society. The solution is mine. Good luck in your studies and good luck on the test.